So welcome to Electronics Isala. So we are in basic electronics lecture series, and today the topic of discussion is the analysis of half-wave rectifier. Okay. So in the previous class we have seen the working of a half-wave rectifier. Okay. So in this class we will derive some formulas for that is the peak inverse voltage. Okay. Then we will derive the DC current and DC voltages. Okay. Then we will derive the RMS values of voltage and current of the output. Okay, of a half wave rectifier. Okay. So let us see in details. Okay. So peak inverse voltage. It is otherwise known as the peak reverse voltage. Okay. So it is the as we see, it is the maximum voltage that the rectifying diode has to withstand or resist. Okay, when it is reverse biased. Okay. So the peak inverse voltage of a diode is the primary importance of design of rectification systems. Okay, so it is the maximum voltage that the diode has to withstand or resist when it is a reverse biased. Okay. So during the half wave cycle of the input voltage, the diode is reverse biased in case of a half wave rectifier. So during the half cycle of the input voltage, the diode is getting reverse biased and no current flows through the load resistance. So we have no voltage drop. Okay. So the that is the whole input voltage appear across the diode. Okay. So let us see the diagram. So you can see when the diode is in the reverse biased, means this terminal is means negative, so it will be reverse biased. Okay. So when it is the reverse bias, so this is our diode. Actually, this is our diode. Okay. So in this case, what will happen is that this is the positive terminal of the diode. So when we are applying the negative half cycle of the input supply, the diode is reverse biased. Okay. So you can see the diode is reverse biased. Okay. So in this case, the no voltage drop across the load resistance. So V output will be 0. But what we have, the whole voltage, input voltage will appear across this diode. Okay. That is the Vm. Okay. So Vm is the peak value or maximum value of the input voltage. Okay. So that is the thing. So the maximum voltage that appear across the diode is equal to the peak value of the secondary voltage. That is a Vm. So in this case, the half wave rectifier, the peak inverse voltage or that is known as the peak reverse voltage is equal to Vm. Okay. So this is the peak inverse voltage in case of a half wave rectifier, which is equal to the maximum value of the input voltage. That is the peak value of the voltage, input voltage. That is a Vm. Okay. So this is the peak inverse voltage. Then peak current. So what is the peak current? So we can say the voltage across the transformer secondary of the peak value of Vm. So Vm is the we have seen that is the peak value of the voltage. The instantaneous of the voltage applied to the rectifier. So this is the instantaneous voltage applied to the rectifier Vi equal to Vm sin theta. So Vm is the peak value or maximum value of the means applied voltage. Okay. So, so the diode has the forward resistance of Rf. Okay. So let us assume that the diode has the forward resistance of Rf, and the current flowing through the diode, that is or load resistance RL, will be given by. So I equal to Im sin theta. So that is the current through the load resistance RL, which will be I equal to Im sin theta. So between 0 to 5. Okay. So it is 0 for pi to 2 pi. So if you see the output voltage in case of a half wave rectifier, so we are getting only one half of the input cycle. Okay, so that is the thing. So this is our 0 to pi, then pi to 2 pi, you are not getting any voltages. Okay, so that is the thing. So I equal to Im sin theta for 0 to pi, and it is 0 for pi to 2 pi. So in this, the voltage is 0 or current also 0. Okay, so that is the thing. So next, so where the peak current flowing through the diode is given by, so Im is the peak current which will be Vm by Rf plus RL. So what is Rf? Rf is the forward resistance of the diode. Okay, and RL is the load resistance. So Im equal to Vm by Rf plus RL. So this is our peak current. Okay. So similarly, so what will be the DC output voltage? Okay. So the DC output you can see we are getting in this cycle, so 0 to 0 to pi. Okay. Then pi to 2 pi we are not getting any voltage. Okay. Because this is diode is reverse biased. Okay. So let us take this area. So that is why we are taking some incremental area, that is d theta. Okay. So let us integrate this. So the average value of the output voltage, that is the V average. This V average equal to area under the curve divided by base. Okay. So area we have to find by integration. This area we can find out by integration. So integrating from 0 to 2 pi. So we are interested about the full cycle, that is 0 to 2 pi. So 0 to 2 pi vi d theta. Okay. So here the base is your 2 pi, total cycle is your 2 pi minus of 0, which is will be 2 pi. Okay. So it is vi is the Vm sin theta. Okay. So it is 0 to pi Vm sin theta, and this is 0. Okay, between pi to 2 pi. Okay. So if we integrate this, it will be 1 upon 2 pi Vm. So this is sin theta. Integrate cos minus cos theta. Vm is take you can take constant. Okay. So minus cos theta from 0 to pi. So the value will be Vm by pi, which will be 0.318 into Vm. So this is the average value or DC value of the output voltage. Okay, this is the output voltage of a rectifier. Average value or DC value of the rectifier. Okay, in case of a half wave rectifier. Okay, so this is what we are getting at the output of a half wave rectifier. This is the average or DC output voltage. Okay. So next is your DC output current. So the average of DC value of output current given by, this is the same formula. So IDC equal to I average integration from 0 to 2 pi I d theta. So similarly, we have Im sin theta between 0 to pi. So pi to 2 pi we have 0. Okay. So if we integrate this, the same result we will get. So Im by pi, that is 0.318 into Vm. So this is the average of DC value of the output current in half wave rectifier. Okay. So next is your RMS value of the current. The RMS value of the current flowing through the diode. So it will the what is the formula? So I RMS square equal to 1 upon 2 pi 0 to 2 pi I square d theta. This is the formula for finding out the RMS value of the current. So I equal to, we know that is Im sin theta. So it is conducting from 0 to pi. So pi to 2 pi we have 0. So 0 to pi Im square sin square theta. So it will be d theta. So it will be d theta and square sin theta d theta. Okay, or you can have. So now this will be Im square by 2, and what will be the Im, sorry, IRMS. So IRMS equal to Im by 2. So this is the RMS value of the output current. Okay, this is the RMS value of the current, okay, flowing through the diode or load resistor. This is the Im by 2. So this is the RMS value of the current. Okay. Similarly, if you substitute Im equal to Vm by Rs plus Rl, we can get IRMS equal to Vm by 2 into Rf plus Rl. This is the RMS value of the current in terms of the peak voltage. Okay. So last one is there RMS value of the output voltage. So this RMS value of the output voltage is defined as VRMS equal to IRS into RL. So it is IRMS equal to Vm by 2 into Rf plus Rl into RL. Okay. So we can get Vm by 2 into 1 plus, you can divide RL here. So it will be 1 plus Rf plus Rf by Rf. Okay. So when Rf is very less than RL, so Rm is the diode resistance, RL is the load resistance. So RL is the load resistance. So it will be much larger than that of the Rf. Okay. So it will be VRMs equal to Vm by 2. Okay. So that we have seen how to find out the average value of voltage and average value of current. Then we have seen what is the RMS value of the output voltage and the RMS value of the output current. Okay, these are very important for finding out efficiency of the rectifier. Okay, so this you need to know what is the RMS value of the output voltage, what is the RMS value of the output current, then what will be the means DC or average value of the input current in the output current, and the DC or average value of the output voltage. Okay, so that's all. So thank you for watching this video. If you have any doubt, you can free to ask me in the comment section. Okay, so we'll see the next analysis of half wave rectifier in our coming videos. Okay, so thank you all. So have a nice day.